Okay, something that's impossible, an event that'll never happen. So in other words, what's the probability of pulling a green card out of a deck of cards? 0. There is no green card. What's the probability of rolling a 9 on a die? You can't. Okay, it's impossible. And then a certain event, an event that all of the outcomes fall under it. So what's the probability of rolling a number that's 1 through 6 on a die? 6 out of 6. Okay. 6 out of 6. You could roll a 1, you could roll a 2, you could roll a 3, 4, 5, or 6. So anything that every event falls into makes it a certain event. And what's 6 out of 6? 1. Okay. So if an event is certain, its probability is 1. So let's talk about what falls into these. So consider the random experiment of tossing a coin 3 times. So what I gave to you at the top is all of the ways that you can toss a coin 3 times. I can end up with 3 heads in a row. I can end up with a tail and then 2 heads. A head, tail, heads. Head, head, tails. Tails, tails, heads. So on and so forth. Okay. You need to decide of these 8, which ones fall into each one of these categories. Okay. So what falls under tossing 2 or more heads? The first one, okay, H, H, H. Well, that falls into that. That's 3 heads. That's 2 or more. The second one, T, H, H. The third and the fourth one. Okay. Only those 4 fall under that category. So if you were actually looking for probability here, your answer would be 4 out of 8 or 1/2. You had a total of 8 different things that can happen. That's the total amount of things that can happen. And 4 of them fall under this category. So that gives you a probability of 4 out of 8. Tossing more than 2 heads. Just the first one. Only the first one falls into this category. So if I had to tell you the probability, your probability would be what? 1 out of 8. This is what we call a simple event. Only one thing falls into it. What about 2 or less heads? 2 or less heads. All of them except, not the last one. All of them except the first one. 2 or less heads means you have 2 heads, 1 head, or no heads. So that's everything except for the one with 3 heads. So I can put THH here, HTH, HHT, TTH, THT, HTT, and TTT. So what's the probability of that happening then?
7 out of 8.
7 out of 8. Okay. Try the next one. Tossing no heads. If you want to bring them, no, it's here. I was going to fold them all up and put them in order so when we go to hand them out next season. Okay, that works. Because I've got the extra socks up here too.
Okay. Okay, you always looking out for
I'll try. Okay. Tossing no heads. What falls into that category?
the last one?
Just the last one. If I'm tossing no heads, that means I'm tossing all tails. So 1 out of 8. What about tossing exactly one tail?
The second one, the third
Okay, you said the second one, so that's THH,
one.
HTH, and HHT. 3 out of 8. First toss is heads.
First one,
The first one,
the third one, the fourth one,
the third one, the fourth one,
and the second.
and the seventh one. 4 out of 8. Or 1/2. Yes. Tuesday, Thursday. Okay. Oh, yes. Yes. Same number of heads as tails.
Can't, no,
Why can't I?
because it's only three, because it's 3.
Because we're flipping 3 times. There's no way to split 3 in half. So that's not possible. This is your impossible event. Okay. It can't happen. And what about 3 heads or less?
Everything.
That's everything. Okay, 3 heads or less means I've got 3 heads happening, 2 heads happening, 1 head happening, or none. So this is all. So this is 8 out of 8 or 1, which makes this my certain event. Okay, it's all 8. Take a minute and try this one. First, you've got to list out your entire sample space. Okay, you've got to list out your entire sample space first. So you're flipping a coin, then you're rolling a die. Let's do those together and make sure everybody's on the same track before you start filling this in. So what does my entire sample space look like? What can I get on my coin? Heads or tails? What can I get on my die? 1 through 6. So I can get heads in 1, heads in 2, heads in 3, heads in 4, heads in 5, heads in 6. Then I can do the same thing with tails. So tails in 1, tails in 2, tails in 3, tails in 4, tails in 5, tails in 6. Okay. So your overall sample space, you've got 12 different things that can happen. Once you figure out the total, you've got to figure out what falls into each category. Like I said, Noah, I did leave myself a little note, so as soon as Power School comes up, I'll get your grade fixed. When you sent it over the weekend, it was down for maintenance, and now it's just crashed or something. We don't know.
Did I do it right?
Mm-hmm. Yeah, it looked good. I just couldn't access Power School to fix your grade over the weekend, and it's still not up. You can't even take attendance right now in the computers. I'm only missing Andrea. Which one of these fall under the category an even number?
H2, H4, H6,
H2, H4, and H6. Those are all even numbers. We can also throw in T2, T4, and T6.
6 out of 12.
6 out of 12. 1/2. Okay, those are all the things that can happen. There's a total of 6 out of all 12, 1/2. What about the probability of a head?
1, 2, 3, 4,
I'm going to shorthand H1 through 6. Okay, it's another 6 out of 12, or 1/2. What about a head and an odd number?
1, 3, and 5.
1, 3, and 5. 3 out of 12, or
3,
1/4. Both are divisible by 3. What about a tail and a prime number?
4.
T1,
3,
3, 5,
4, 2,
2. 2 is the only even number that is prime. 2 is only divisible by 1 and itself. So 4 out of 12, 1/3. What about numbers less than 7? That's all. A number that's less than 3.
H1 and 2, T1 and 2.
H1 and 2, T1 and 2. 4 out of 12. What about a 7 is rolled? None. That's impossible. Unless you magically changed your die. If it's anything like that crazy girl that my daughter likes to watch on Amazon Prime. It's- Oh, with all the 27 freaking numbers on it. No, my daughter watches this crazy show. It's called Wish and Poof. It's about this little fairy that gets these magical wishes, and she's like, frog, wish and poof. And she turns into a frog. I don't know. Kids' cartoons are dumb nowadays. I don't know. I can't. I want old school Teenage Mutant Ninja Turtles, Rocket Power, SpongeBob, Scooby-Doo. Questions? All right. Let's actually find some probabilities and we'll be finished for today. So, a probability assignment, a function that assigns to each event a number between 0 and 1. So, notice all of these probabilities that we got, 1/2, 1/4, 1/3, even back here, 3/8, 1/8. Everything that you get is a number that is no less than 0, because we can't have a negative probability, but it's no more than 1. Okay? Probability can also be decimals. 1/2, 0.5. 1/4, 0.25. 1/8 is, I don't even know. Sorry. Don't know off the top of my head. 1/3, 0.3 repeating. Okay? So it can also be a decimal. Probability should never go any lower than 0. Again, you cannot have a negative probability. So if it can never occur, your probability is a 0. If it's everything in the set, its probability is 1. Okay, so that means everything that falls in between, if I add them all up, it should equal 1. Okay, so if you think about it, let me extend this. So if we talk about a die, what's the probability of a 1 on a die? 1 out of 6. What's the probability of a 2? 1 out of 6. 3, 1 out of 6. 4, 1 out of 6. 5, is a 1 out of 6, and a 6 is 1 out of 6. Okay, these are all of the events that can happen on a die. Well, if I add up 1 out of 6, 1 out of 6, 1 out of 6. Oops. Wow. I can't write today. Can't think today. Okay. If I add up each one of those events, everything that can happen on a die, that gives me 6 out of 6, which is 1. So all of the small events, when you add them together, should always equal 1. Okay? Even with a coin, landing on heads is 1 out of 2. Landing on tails is 1 out of 2. If I add both events together, I get 1. Okay? So all of the small ones equal 1. Questions? Okay. With that being said, 6 players are in a tennis tournament. Anna, who's a Russian female, Ivan, who's a Croatian male, Leighton, okay, we'll go with it, Aussie male, Roger is a Swiss male, Serena is an American female, and Venus is an American female. The only two I know of there are Serena and Venus. I don't know. Okay. Sample space is who will win the tournament. So who can win my tournament? List out all of my options to win. Anna, Ivan, Leighton, Roger, Serena, and Venus. Okay, we listed them all out, just like you listed heads 1, heads 2, heads 3, heads 4. Those were all of my options. These are all of my options to win. Okay. So right below that, they give you the odds for everyone to win except for Serena. They tell you Ivan has a 0.16, Leighton has a 0.20, Roger has a 0.25, Anna has a 0.08, and Venus has a 0.16. So what does that leave Serena having, and how do you know that? What is Serena's probability of winning, and how do you know? Subtract them from what? 1. Remember, all of your individual people, all of your individual things that happen, when I add them up, my total probability should always equal 1. So when I add all these up, I should equal 1. So 0.16 plus 0.20 plus 0.25 plus 0.08 plus 0.16. 0.85? 0.85 is the total for everybody but Serena. Which means to get 1, I'd have to add on 0.15. So this means Serena has a 0.15 probability. Okay. Okay, it should always equal 1. Okay? So, now that we know that, we can answer these questions. What's the probability that an American will win? Well, who falls under that category? Serena and Venus. So, Serena had a 0.15 and Venus had a 0.16. 0.31 is the probability that an American will win. With those odds, do you think an American's going to win?
Nope.
No. not very good odds. It's not even half. Okay. What's the probability that a male will win? Ivan, Layton, Roger. Ivan, Layton, and Roger. So 0.16, 0.20, 0.25, 0.61. That's actually pretty good odds. Males rule. Sucks. What about the probability that an American male will win? None. This is impossible. Okay, so your probability here is 0. We don't have any American males. All we have is American females. Okay, what's the probability that a European will win?
None.
Think about what's in Europe. Oh, we're throwing history in with math. Who falls into this category?
Russia.
Okay, so Anna,
And Roger.
Roger,
And Ivan.
Ivan. Anna, Roger, and Ivan fall into this category. So 0.08 plus Roger was 0.25 and Ivan was 0.16. So 0.49. The last one. What's the probability that a female will win? 0.39. That's your Anna, your Venus, and your Serena. Okay. Without adding all three of those up, what else could I have done? Good. We already found out this is males. Well, males and females should add up to equal 1. So I could have done 1 minus 0.61 and got 0.39 as well. So there was 2 different ways to attack that one, if you really thought about it. We are almost done, my friends. So when we don't know what they are called, they throw in symbols. Okay. So here's your first outcome. So this could be like probability of getting a 1 on a die, probability of getting a 2. These are all of your individual outcomes. Okay. Again, to get all of them, we add them all up and they should always equal 1. So they can give you questions like this. Consider the sample space. We've got 4 things happening. 1, 2, 3, 4. Okay. They say if all of the outcomes are equally likely, what are their probabilities? Each one of these should have the same probability. They are equally likely. 1/4. Okay. So that means event 1 plus event 2 plus event 3 plus event 4 should equal 1. Okay, if they're all the same, that means they can all be the same variable. So if I go to solve this, I've got 4x on the left-hand side. X plus x plus x plus x is 4x, and that should equal 1. Divide both sides by 4. X equals 1/4 or 0.25. Each one of these would be 0.25. Okay, in part B, they tell me the event 1 is 0.3, event 2 is 0.25, event 3 is 0.17, but they don't tell me anything about event 4. But we know if I add all 4 of these up, it should equal 1. So 0.3 plus 0.25 plus 0.17 plus some event that I don't know, again, make it a variable, should equal 1. Well, when I add up these 3 events that I do know, that's 0.73. 72, yeah. Sorry. 0.72. And then to finally get x by itself, we need to subtract 0.72. Which means x should equal 0.28. Okay. Now they tell me that 1 is 0.18, event 2 is 0.12, and 3 equals event 4. What's the probability of event 4? How do I set this up as an equation? Like I did here. Remember, we've got to do 1 plus 2 plus 3 plus 4. So what's 1? 0.18. What's 2? 0.12. How do I represent 3 and 4 when I don't know what they are? Okay. Remember, in order to be able to solve, we have to stick with one variable. So if 3 is x, what is 4? Why? It says that they're the same. So if they're the same and I make 3x, that means 4 is also x. And again, that should equal 1. So 0.30 plus 2x equals 1, which means 2x is equal to 0.7. And when I divide by 2, my x's are 0.35. More and more complicated as we go, as always. Ha 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 ha. Okay, this time they don't tell us anything about any of the probabilities, number-wise. But I can represent these. Remember, we need to try to stick to one variable. That way we can solve. So I don't want x, y, and z. I want to use one variable and write them all in terms of one variable. So it says 1 is double 2, and 2 equals 3, which equals 4. What are all the probabilities? Is this one not in your pad here? All right, we're going to do it anyway. Okay. So you said what? Okay. So he said, well, if 2, 3, and 4 are all the same, they can all be the same variable, x. So if 2, 3, and 4 are x, what do I make 1?
This is
In terms of x, what? 2x. It says 1 is double what 2 is. So if 2 is x, double that would be 2x. So here you would do 2x plus x plus x plus x equals 1. So then 5x equals 1. And when we divide by 5, every x is 0.2. Careful though. What does my question actually say? What are all the probabilities? So if x is 0.2, this is 0.2, this is 0.2, this is 0.2. What is this though? Okay. So just be careful and make sure you're answering the question. What do we got? Just example 2 and 3 left? Is that it? Or just 2? Oh, no, 2 and 3. Okay. We got this. Yes, we do. Goodness gracious. Okay, this time I've expanded. Your sample space is not 4 numbers now, it's 5. I want all of my outcomes to be equally likely, so I want them to be the same. What's the probability of each one of these? If they're all going to be the same. They're all going to be x's. So I've got all of my x's. There's 1, there's 2, here's 3, 4, and 5. And they equal 1. So 5x equals 1, which means x is 0.2. They're each 0.2 if they're equally likely. Okay, part B gives me 1 is 13, 2 is 0.24, 3 is 0.27, 4 and 5 are equal. So what can I make 4 and 5? X. So these are both x. So again, 1 plus 2, whoops, not 5, 4, plus 2 plus 3 plus 4 plus 5 should equal 1. So that's 5, 6.64. 0.64 plus 2x equals 1. So 2x equals 0.36. Divide by 2. X equals 0.18. Did I answer my question? What is the probability of 4? Well, 4 was x, so yeah, we're good. Okay? Let's see what you can do with this one. It gives you 1. It gives you 2. And then it says 3 is equal to 4 and 5 put together. But we don't know anything about 4 and 5. Okay, so Ashley said, let's add the first 2 together. Okay, so event 1 plus event 2 is going to give me 0.38. Okay, so 0.38, what do you want to do with that now? I agree with where you're going with this right now.
Since we already know 4 and 5 and 4 and 5.
We don't know anything about 4 and 5.
Well, if it says each battery equals 4 plus 5, so you have to
Wait, you said subtract 0.38 from what?
1.
1, okay. So 1 minus 0.38 gives me what? 0.62? 0.62. What is 0.62?
Is 3, 4, and 5.
3, 4, and 5 together. 3, 4, and 5 all put together. That's what 0.62 is. They want to know what is 3. So let's make 3 my variable. 3 is x. If 3 is x, what's 4 and 5?
X.
4 and 5 put together as a whole is x. Both of these added up equals 3. So if 3 is x, both of these together are x. So that means half of this is 3, and the other half of this is 4 and 5 put together. So 0.62 divided by 2 is 0.31. So that means event 3 is 0.31. That means that event 4 could be, I don't know, it could be 0.2. And event 5 then would be 0.11. We don't know though. And do we care? No. All I really needed to know was what was 3. I don't care what 4 is. I don't care what 5 is. Okay? So be careful. They are going to leave off a lot, and you're going to sit there and you're going to rack your brain thinking, I need to figure out what 4 is. No, you really don't. We don't care what 4 is. We don't care what 5 is. Okay. All right. One more and we are finished. One more and we are finished. Okay. We're back to 4 different things. A, B, C, and D. They tell me that A is 0.18, B is 0.22, and C is double D. So we need to add A, 0.18, plus B, 0.22, plus C, we don't know, plus D, we don't know, but we know they should all equal 1. How do I fill in for C and D?
X and 2x.
X and 2x. C is double what D is. So we're going to make dx, and C is double that, so C is 2x. So we end up with 0.4 plus 3x equals 1. 3x is 0.6. So x is 0.2. The last thing you need to ask yourself is, did I answer my question? What's it asking for? It's asking, what is D? Well, D is
D is X.
D is X. C is double. D is not. So this is D. You answered your question. It says C is double, not D is double. Okay? A lot of people get confused because they throw the word double right in front of D. So they're thinking D is double. D is not double. And if you double that, it will be wrong. Please understand, I guarantee you they're going to give you that answer and the correct answer. So they're going to give you 0.4 and 0.2 just to see if you're paying attention. Okay? A is 0.34. B, C, and D are all equal. So A plus B plus C plus D equals 1. B, C, and D are all equal. So they're all X. So 0.34 plus 3x is equal to 1. 3x is equal to 0.66. And x is equal to 0.22. Did we answer the question?
No.
No. We know that A is 0.34. So what's B? 0.22. What's C? 0.22. What's D? 0.22. Now you have answered. How do I check myself?
Add
Add them all up. If they don't equal
one.
1, you've got a problem. Okay, last one. A is double B, and B equals C, which equals D. What are all the probabilities? Okay, so I need to add A plus B plus C plus D, and that should somehow equal 1.
2x plus x plus x.
Okay, so A is double what B is. So we'll make A 2x, which means B is x. Well, if B equals C equals D, that means C and D are both x. So 2x plus x plus x plus x. So 5x is 1, which means x is 0.2. They want all of the possibilities. So A, they want all of your probabilities. What is A? 0.4. What's B? What's C? What's D? And again, if you add all these up, that should equal 1. If it does not, you did something wrong. The next page in your packet is your homework. Okay, front and back. Just like we did. Okay, you will be able to rip it out and hand it in. Okay, I am collecting this. This is not going to be a yay, you did it. This is going to be, I'm actually grading this. Make sure you do it. You have plenty of time to get it started right now. That way, if you have questions, I am here to help you. Okay. If for some reason you finish super early, you are welcome to a laptop to work on your web. So everybody is project free from here to the end of the year. Yeah, we're not going to talk about that. Yes, ma'am.